Okay guys, welcome to your third video. In example 2, we're going to look at an 8 kilogram object that moves upward from an initial position of y, a height of 0, and it has initial velocity of 20 meters per second. We want to determine the maximum height that it'll reach. Okay, so what this will sort of look like is, let's say that we have a flat surface that kind of moves up to an incline. At the bottom of that surface, height is equal to 0. Okay. There we go. We want to figure out the final height that our object will reach. Okay, let's say we have some box here. Mass is 8 kilograms, and our initial velocity is 20 meters per second. Okay, so here we're going to start off with the conservation of energy. So the initial energy must be equal to the sum of the final energies. Okay, so we have our equation: initial potential plus initial kinetic is equal to final potential plus final kinetic plus heat. Okay, initially our object is on the ground, right? When it's on the ground at a height of 0, it has no potential energy. It does, however, have a velocity, so it will have kinetic energy. Later, at the top of its path, okay, it's going to be some height from the ground, h. Okay, so we know it will have potential energy. We assume that at that position, at the top of the incline, it will have no velocity, so our kinetic energy will be 0. We also know nothing about friction. Okay, so we assume that there is no thermal energy in this situation, that there's no friction, so there must be no thermal energy. Okay, so to continue on with our equation, okay, for kinetic energy, I have a half mv squared is equal to mgh. Okay, so I'm going to have 1/2 the mass, which is 8 kilograms, times my velocity, which is 20 meters per second squared. Sorry guys, it's difficult on here to write these numbers accurately. So just give me 1 second. There we go. Okay, so we have a velocity of 20 meters per second squared. That's equal to 8 kilograms times 9.8 meters per second times the height of our object. So I'm going to get 1600 joules, okay, is equal to 78.4 times h. Okay, and that's meters squared per second squared, or the units there. Divide both sides by 78.4 to get h by itself, and we determine that our object will reach a height of 20.4 meters from the ground. Okay, so that's the same as my final position. Okay, it will be 20.4 meters from the ground, and that's assuming, again, that friction is negligible, so there's no kinetic energy that is transferred to heat, and that all of the kinetic energy is transferred to potential energy. And if that is true, then the object will reach a height of 20.4 meters. Okay, stay tuned for your last video on example 3.